Hi, I'm Liam from Topos Labs, and today I'm going to demonstrate how to build a model in Gracie. Gracie is a no-code text analytics platform that enables non-technical users to build models for unstructured text with zero need for natural language processing or machine learning experience. For this example, I'm going to build a research paper classifier within Gracie. The end result will be that I'll be able to give Gracie any kind of text and have Gracie tell me if it looks like a research paper. I have one research paper here to see what she already knows. If we paste it in our editor and process, we can see the results. What we get back is everything of value Gracie has found in this document. We can see here that Gracie has classified this text as being about building and construction as a main category, with a main topic or subcategory of manufacturing. This classification is from our out-of-the-box ontology, which contains over 30 dictionary models, 200 topic models, 7,000 lexemes, and 150 document types. This is great so far. I haven't built any custom models, and we already have some good information. If I open up the stats screen, I can get a deeper look at what Gracie thinks. Here we can see the top 3 dictionaries and the top 3 topics of each's classification. The low proximities tell us that while some language from these are present, there isn't enough for us to consider this a true positive. This helps us because Gracie isn't forced to make a decision about what something is and lets us know if she's not sure what she's looking at. If I navigate to the Skill Sets tab, we can see that there are no results. So far, it's plain to see that we know what this document is about, but we don't know what this document is. To build the research paper model, I can go to Skill Sets and create a new skill set called Research Paper. Within this skill set, I can make a new skill called General Research Paper. I'm calling it General because I don't want to make a model too focused on one particular field of study. I want it to be able to understand research papers from any field of study. We're now inside an empty skill. Here's where we can build and edit our model. To start, we can upload training text. These will be research papers that we use to teach Gracie. To start, I will only add 26 examples of research papers to see if we're on the right track. Now to build a model. I can click the Build Model button at the top of the screen. As you can see, the process took roughly 1 second. This is made possible from our global language ontology, a patented method we use to build models with very few training texts, no negative examples, in seconds. We can see Gracie has also generated a word model to help this classification. I can edit this to give Gracie a better understanding of what I'm looking for. I can remove bias that's appeared through the building process to prevent Gracie from misclassifying, and I can reinforce features and words that are important to what I'm trying to classify. This human-machine teaming produces better results faster than other traditional machine learning methods. At this point, I have a fully functioning model, so I can go back to the editor to see if we're picking up the research paper. As you can see, we are now classifying this as a research paper, which is perfect. At this point, our model is looking good. We have successfully built a research paper model in 1 second using only 26 training texts and no negative texts. The next step in this process is to QA our model. To do this, we can navigate to the Validation tab within the skill. This area is where you can create a testing suite to ensure your model is accurate in the environment it will be operating in. Here I can add negative testing sets, in this case, things that are not research papers, into this new negative group called Research Paper Articles. I'm adding articles on how to write a research paper. While the language should be similar to research papers, they are not examples of them. These should have true negatives and should have a low proximity. In a positive bucket, I can add our true positives, which are the research papers themselves. After this process is done, I can click Start Run and get my score. We now have a star rating for the model. This is based on the F1 score, so we can see at a glance how well this model is performing. In this case, our model is performing very well, with an F1 score of 0.96 for this testing environment. I can also visualize my results. This will help me understand where I need to improve my model's performance based on the testing environment I've set up. Here we can see the range of proximities for each testing set's documents. If I click on one of the bars, I can see those documents appear on the right. If you look on the right, you can see the purple, or the document model's influence, is usually the smallest part of each proximity graph. This is telling me that my document model is underperforming, and that adding more training text will increase accuracy. On the other hand, my match list, the blue in this graph, is performing well. This makes perfect sense. We've only used 25 training texts, so Gracie doesn't have a complete understanding of what research papers are. However, we're already showing a great ability in disambiguating between texts talking about how to write research papers and texts that are research papers themselves. If your F1 score meets your needs, you're done. In this case, a 0.96 F1 is more than enough for us to use this in production. When compared against competition or DIY solutions, Gracie's time to value is in a class of its own, with other tools requiring drastically more training text, negative examples, and days or weeks more of additional building time to accomplish what we accomplish in minutes. If you're interested in hearing more, visit toposlabs.com for more on Gracie's capabilities, use cases, and out-of-the-box models.